All right, boys and girls, a little calculator help here. First thing, did you know that you can do scientific notation in your graphing calculator? So I was talking to Mr. Arnold, and he kind of showed me this, but we don't do a lot of scientific notation anymore, although we should. It's very important in chemistry and physics when we're measuring huge things and really small things. So, like, let's say we had something that was really small. I don't even know my units, but we'll say it was 1, 2, 4, 5, 6, 8 times 10 to the negative 17th. So it's like a really, really small thing. This EE thing, not to be confused with E, okay, that's just confusing. This is scientific notation. So you hit second, comma, and that gets you to EE. And then I said negative 17th. So let's say we have some tiny little particle. It's that big, and we find 20 of them, and we want to know how big all 20 of them are. So we would multiply it by 20. And see, this is the thing. This is why this is helpful, because doing this by hand or even on just understanding how to do this is important because it's kind of counterintuitive. We're multiplying this by 20, and this is going to turn into a negative 16, probably. So that is how much 20 units of this would be or would weigh, maybe. All right, so that's scientific notation. Now, on to the pre-calculus. This is actually calculus. You'll see this is 1, 2, question number 1. And what I want to show you here is how to use your table in a way that we probably haven't used it before. So I'm going to get into my fraction by going alpha y. And now I can do 8 times the sine. Sorry, this is not very fast on here. It's much faster when you use your good old-fashioned Texas instrument. Remind me to talk to you about what a racket that is someday. All right, I hit second table. This is what you're used to getting. They go up by ones. But if you go to your table settings and go down to the independent variable, let me ask what to put in for my independent variable. Hit enter and then go back to my table. And look, now I can put them in. So we got negative 0.1, enter, negative 0.01. Okay, I'll spare you me reading myself touching it, but you get the idea. Let's see, now we'll do 0.001. So obviously I showed you how to do this, but now I'm going to explain to you what the heck this problem is talking about. All right, so that's like the quickest way you can get all those values. And if you do it like in your graphing calculator, it is much quicker than using the web-based one here. But what is this trying to tell you? All right, well, the limit does exist here because as it approaches it from the left and as it approaches it from the right, that both leads you to the same number, which is 8, the same point. But the reason why we can't put in a 0 is like, look what happens when you put in a 0. What happens when you divide by 0? It gives you an error. So this is a tactic that you're using to help you understand the limit process and why it exists. It's going to end up leading you to important points. This point's going to be important, and that'll be coming after you learn a little bit more about derivatives. All right, good job. Boom.